is welcome and introductions. I'm going to introduce myself in just a second. A little bit of a Leland overview, and then on to the main course here. So we'll do mixtures and solutions, advanced frameworks, and these are really advanced weighted averages problems, and they're starting to show up a lot on the test. So want to make sure that you guys are comfortable with it, and then we'll do a quick recap. All right. So my name is Bruce. I have my MBA from Wharton, and I've been coaching the GMAT and GRE for a long time. So over 10 years. I'm the founder of First Choice Admissions. I did the UCLA GMAT and GRE programs for years, and now I'm doing it here at Leland. And sometimes I also speak to the media on things like, admissions and test prep and that kind of thing. So before we kind of dive into the actual, kind of event here, I do want to address kind of the elephant that's in the room. And it's this. Everybody here is probably, if I ask, raise your hand if you're finding that this application process to business school is significantly harder, significantly longer, more stressful, and this is really important, kind of more lonely and uncertain than you were expecting. Like, I bet every hand here would go up because it's hard to do what you guys are doing. So if you need some help, Leland coaches, absolutely impressive. If you look, just kind of scroll on any of the Leland coaches, oh my gosh, very, very impressive people. They've done it. They can absolutely, most importantly to you guys, a good job. I'm glad that you can score well on the GMAT, but they can help you guys score really well on the GMAT and GRE. They have a track record of doing that. And you know what? It's just great to have an expert who's on your side. So if you're feeling like you could use a little extra help, strongly recommend getting a coach to help you out, point you in the right direction. I know it's expensive to help things out a little bit. I've got a special offer for GMAT and GRE week. We'll talk about that at the end for folks who might be interested. Okay, so what we're going to cover today is we're going to cover essential frameworks for mixtures and solutions, which I said are really advanced weighted average problems. And we're going to go through a lot of practice questions. So let's take a look at a mixtures question, which might be something like this. In fact, in this case, it is something like this. Kathy's Candies sells chocolate creams and chocolate-covered caramels. The creams sell for $5 per pound and the caramels sell for $9 per pound. How many pounds of creams would be in a 10-pound mix that sells for $8 a pound? All right, so for those of you who are looking at this and saying, well, Bruce, this is just a weighted average problem, like, you're not wrong. We could solve it as a weighted average problem for sure. Total number of pounds is 10. Average price for the total, $8 a pound. All right. Price of creams, they give us that, $5. Price of caramels, $9 a pound. And we're asked to find the number of pounds of creams. So all we need to do then is say, well, we know the number of creams, right? That's X. What's the number of pounds of caramels? How do we express that? Well, you might be saying to yourself, well, maybe I'll use Y. Maybe the pounds of caramels is Y. That's dangerous. We actually can't do that because if we introduce two variables, guess how many equations we need to have in order to solve? Two. How do you think the GRE and the GMAT are going to be nice and give you two equations? No, we're definitely in the land of one equations. So here is something that is just throughout the test. Really important concept, occurs everywhere. If you absolutely have to express things in one variable, and we do, I want you guys to always remember this. If A plus B equals total, then total minus A must equal B. So the total number of pounds we have is 10. The number of pounds of creams we have is X. Total minus X must be the number of pounds of caramel. Caramel must be 10 minus X. And just like that, we have this thing in one variable. That concept right there, super important. It's all over the test. Well, but now that we have the number of everything and the value of everything, can we just put that into a weighted average formula? Sure, we can. We can put it into that right there. And if we wanted to, next step to solve that, well, you know what? Let's just multiply both sides by 10, and we're going to get 5 times X plus 9 times 10 minus X equals 8 times 10, right? Easy peasy. We don't have to go through all the routine of setting this up as a weighted average because we can use this last part as a very effective framework. So notice what we have is we have thing one, right? The creams. We have the value of the creams, $5. The number of creams, X, right? We don't know. Thing two, we have the value of thing two, $9, plus the number of things, right? 10 minus X. And if we add those things together, that's going to give us our target. Target, value of things times the number of things. Is everyone comfortable where that comes from? Just from the algebra, right? This is super important. And again, this is all over the test. If you're lucky enough to get a framework, and the truth is that all of these questions have frameworks, we always use the framework. So the framework we have is thing one, value times the amount, thing two, value times the amount, equals target, value times amount. The framework is always twice as smart as you and me put together. So now that we have the framework, we're going to use the framework. So let's see, and this framework does two things for us. First of all, we go through the questions really fast. And two, the framework lies right on top of how they ask the questions. So it's a very, very good tool to break the questions down very quickly. And let's see how that works in like actual real life here. Let's take a look at the Kathy's Candies one, right? Instead of going all the way through that, weighted average thing, we can just pick out the individual elements, drop them into the framework, and go. Value of creams, $5. Value of caramels, $9. Amount that we have to, end up with a target amount, 10 pounds, right? At $8 a pound. So we have value and amount for target. Creams, I don't know how much they cost. That's what we're being asked for. X. How many caramels must we have? Well, it must be 10 pounds minus how many creams we have. So 10 minus X. Now all we do is solve that. Boom. And when it comes to, there are lots of different ways to go through the algebra and to go through the arithmetic here. And I don't want you guys to get hung up on that in this particular presentation. Lots of ways to do it. But you're going to find that X is 2.5. And again, the framework just allows you to know exactly what you need to pull out of the question and just do it very quickly and solve very quickly. Okay, let's try another one. I'm going to give you guys about 2 minutes. See if you can set this one up in the framework. Go ahead. And then after you've been doing it for a couple minutes, check back in and I'll show you how I did. About 1 minute in, I'm seeing some people still working. And by the way, the important bit on all of this is setting up the framework. The actual algebra and arithmetic, less important for right now. It's being able to set up these frameworks. Because every one of you, I'm sure, has better arithmetic and algebra skills than I do. So all you need to do is set this thing up and then go. So let's talk about how we set this up. So what we've got, Colombian costs $10. So that's the value of Colombian. House costs $4. That's the value of house. Target, well, we're going to have 100 pounds of it. And what's the value of our target? How much per pound? 5.5. All right. How much Colombian are we going to have? Well, I don't know. That's what we're being asked. X amount. If we have X amount of Colombian, how much house are we going to have? Well, we're going to end up with a total of 100 pounds of this stuff. So, and part of that 100 pounds is going to be taken up by Colombian, X. So the value or the amount of house rather is 100 pounds minus however much Colombian we have, or 100 minus X. And then all you do is solve. And again, I don't care too much about the arithmetic and the algebra at this point. The important piece is to be able to set up the framework. Okay. This framework is very flexible because it's not always just dollar amounts. We can mix a whole bunch of different things. Take a look at this one, which is mixing wins and losses. So I'll give you guys about a minute or so. And again, don't worry about the algebra. I want you guys to pick out what's going on. See if you guys can populate the framework. That's the most important thing. So again, give you guys about a minute. Use the framework to guide you. Let's go ahead and populate that framework. Okay, let's take a look at what we're being told here, and we'll just populate the framework with what we're being told. So what we've got is in the first part of the tournament, so part one, won 60% of the games. So the value, right, percent games won, 60 over 100. During the rest of the tournament, 3 out of 20, that was the value, right? Games she won, 3 out of 20. And we know actually the number of games she played must have been 20. And then the target, well, 40% of the games she played. That's our target. How many games did she play? Well, notice they don't tell us how many games she played in part one. We know how many games she played in part two. We don't know how many games she played in part one. N games or X games, doesn't matter, whatever variable you choose. And so the target must be 40% of how many? Well, N plus 20. Making sense to everybody? All we're doing, picking it up, dropping it in. And at this point, it's math and it's algebra. And again, I don't care too much. I want to, animate this so that you guys have it. So you can look back, see how I did it. Now, this is important though. When you solve for N, and you're totally going to solve for N, what have you found? You found the number of games that she played in part one. What are you being asked for? You are being asked for the total number of games she played. So you need to add part one, which is when you solve it, it's going to be 25, plus part two, which is 20. So the answer is 45. And you can absolutely bet your boots that 25 is going to be one of the answers. Makes sense? We need the total number of games. So that's N plus 20. We know that N is 25, so 25 plus 20. Okay. Let's do another one. Same kind of idea here. Let's go ahead, give you guys a minute, and populate this one. It's a little tricky, just be very literal. Write down exactly what you know for the original. You're going to add a score. Write down the added value of the score and how many there are. And calculate your target. All of the information will fit into the framework. The framework will lie right on top of how they ask the questions. It comes right from the DNA. Looking at about 1,000 of these things. Okay, let's kind of look at this. So what are they saying? Well, they're going to start us off with the original test score, right? The value 80, right? As the average score is 80. There's your value. How many of these were there? N, right? That's how many we had. Well, then what happened? Well, we added a score. What was the value of the score we added? 85. How many 85s did we add? Did we add 7? Did we add 10? Well, they tell us 1. 1 additional score. 1. So we're also given the target. Man, that was 81 was the target, and we know how many scores there are. N plus 1. That's the number of scores. The value is 81. Do the algebra here, N equals 4. I find if you guys are finding this one like challenging in the wording, because most, by the way, of the GMAT and GRE is all about getting from English into math. I find this one a little challenging too. It's a little confusing, but it will absolutely break down into the framework if you're just very literal about the framework and you're looking for very specific things. Let everybody take a note or two, and then we will move on. So mixtures, this framework, man, as long as you're kind of combining two things to get a target, this is the framework for you, and it will do it really fast. Let's talk a little bit about the solutions framework, which is actually, it's very, very similar to the mixtures framework, but it's easier. It's easier, and here's why. With the mixtures framework, that value, that can sometimes be confusing because it could be anything, right? On the candies thing, it was the price of something, right? On the one we just did, it was the average of the test scores, right? Of the card player. It was the average of games that they won, right? Solutions tend to be a lot more straightforward, and it's still the value of things times the number of things, but because that's how all averages work. But we know what the value of things are. The value is going to be some percent. And whether they tell you that's a percent or a ratio or whatever, it doesn't really matter. It's always the percent is the value times the amount you have. Percent is the value times the amount you have. Percent value times the amount you have. And so it's often a little bit more straightforward because it's a little easier to pick out the value. But other than that, it's going to work basically darn near exactly like mixtures work. All right, let's take a look at one here. So how many gallons of a 10% antifreeze solution need to be added to 40 gallons of an 80% antifreeze solution to create a solution that is 50% antifreeze? Okay, so what we always do is we read carefully and we pick out what's the original amount and value that we're given. And let's read carefully. So we start out with 40 gallons of an 80% antifreeze solution. That's what we start with, right? If we read carefully, yep. And then we're going to add to that, right? We're not going to stay there. We're adding to that. What are we adding to that? Well, we're adding a 10% antifreeze solution. How much of a 10% antifreeze solution are we adding to our original? Well, we don't know. That's what we're being asked. So we're given the target. We're given the target value. 50% antifreeze solution. How much of this antifreeze solution are we going to have? Well, let's think about it. We started out with 40 gallons of it, right? But we're going to add to that. How much are we adding to that? X amount. That's how much we're adding to it. So when we add it all up, we have 40 plus X. That's how much we have. Now it's just a matter of cranking through the math. And again, I don't want to get hung up on the arithmetic or algebra. There are a ton of different ways to do this. However you guys feel comfortable doing it, so long as it's fast and accurate, it's okay with me. And if my arithmetic is right, and that's like, there's a good 1 in 3 chance they did this right, you're going to find that X is 30. Right. So the tricky bit can sometimes be getting the target amount. And that's just saying, look, the target has to be the original amount plus the added amount. In this case, it's 40 plus X. Let's try another one. What concentration should 4 quarts of salt water have so that when it's added, to 5 quarts of a 40% saltwater solution. The resulting solution has a saltwater concentration of 33 1/3%. Wow, that's a mouthful. All right. What are we being asked for in this case? What concentration? Oh, so we're being asked for a value here. What concentration of 4 quarts of salt water have? Oh, and we're going to add something to that. Got it. So we have what concentration, X over 100, right? We don't know that percent, that concentration, but we know we got 4 quarts of it, and then we're adding something to it, right? What are we adding? Well, we're adding a 40% saltwater solution, and we know how much we're adding. We're at 5 quarts to that. And what's the target? 33 1/3%. And how much of it will we have? Well, we always add the original amount plus the added amount to get the target amount. 4 plus 5 is 9. And at this point, again, it's just kind of cranking through the algebra here. I tend to multiply everything through by 100, but it doesn't matter. Tons of different ways to do this. But I think when you do it, you're going to find that X is going to be 25. I want to talk about ratios for just a second, because when you're in the land of solutions, right, percents and ratios, there's no difference. They're the same thing. So they can start to play ratio games with you when you're in solution problems. And this is huge insight into ratios. And again, this also appears all over the test. When you're given one ratio, you have actually been given 3 ratios. And it works like this. Let's say there is a pie contest and there are cherry and apple pies. Only 2 kinds of pies entered in, but cherry and apple pies are entered into the contest in the ratio of 3 to 5. So 3 cherry pies for every 5 apple pies. That one ratio, you can actually get to 2 other ratios. Because that means, look, there may have been 3 cherry pies and 5 apple pies entered into the contest. Cherry to total must be 3 to 8, right? If there were 3 cherry pies and 5 apple pies, there would have been 8. If there had been, 6 cherry pies and 10 cherry pies, right? That's 16. But the ratio, the total is still always going to be multiple of 8. Cherry is going to be multiple of 3. Apple is always going to be multiple of 5. So cherry over apple is always going to be 3 to 8. Apple over total is always going to be 5 over 8. That's huge. Because here's what they love to do. Like, they love this. So what they'll do is they're going to start you out with cherry over apple, right? That's what they're going to give you. But that's not what you're going to need to solve the problem. What you're going to need to solve the problem is like apple over total. And they're going to expect that if they give you cherry over apple, that you can get to apple over total. They like that a lot. So this comes up in solutions. And it comes up like this. Let's go back to our antifreeze solution. So notice that the entire ratios that we use, this 80 over 100, this 10 over 100, this 50 over 100, those were all antifreeze over total, antifreeze over total, antifreeze over total. And this whole question was about antifreeze. And by the way, how do we know this question's about antifreeze? That's what you added. Almost always what you added is what the question's about. So this whole thing's over antifreeze. We need everything over antifreeze over total. Let's say they would have given us antifreeze over water, right? There are 2 things. You got antifreeze and water. I'm going to give you antifreeze over water. No, we need to convert that into antifreeze over total. That becomes pretty important. Let's take a look at one that asks us to do exactly that. So the optimal blend of synthetic motor oil for a Formula 1 race car is a mix of monocarbonate and biglyceride in a ratio of 4 to 1. That's not actually true. I just made that up. But if the engine currently contains 20 ounces of synthetic oil that is 30% biglyceride, how many ounces of monocarbonate must be added to the engine to achieve an optimal blend? Whoa. Okay. They're giving us lots and lots of ratios. The first thing I want you guys to pick out and realize is we're adding monocarbonate, right? So this whole question is about mono. We need every single ratio in this thing to be mono over total. Let's start with target. So target, it doesn't give us mono over total, right? It gives us mono over bi is 4 over 1. That's okay. We mean that we know for sure that mono over total must then be 4 over 5. So our target, right, percent, our target solution, 4 over 5. Let's talk about the original. What did they tell us in the original? Well, in that race car right now is 30% biglyceride. That's bi over total is 30 over 100. Well, do we want bi over total? We do not. We want mono over total. Well, bi over total is 30 over 100. Mono over total must be 70 over 100. So 7 over 10 is our original percent. Okay, so we know we've got 20 ounces right now in the engine. We're being asked, how much more do we need to add? Okay, well, what are we adding, by the way? Are we adding some watered down solution of mono, or are we just adding in like full on, just full strength mono? We are. It is 100% monocarbonate that we're going to pour into this engine. So it's 100% or 1. And so the target, how much is going to be in this engine? It's going to be 20 plus X, because we always add the original amount plus the added amount to get the target amount. So you had to understand, to do this one, you have to understand that the whole thing's about mono, and you have to flip whatever ratios they give you, right? Using that 1 ratio is 3 ratio rule. You got to get everything into mono over total. And then at this point, it's just algebra. And I'm sure you guys will be able to solve it. That's how that one works. Okay. The other thing that's starting to come up, substitutions. And these look harder than they are. Basically, what we have to do to get these is we still use the same framework, but we have to work backwards is what we have to do. So let's take a look at how this one works. Rahul has a full bottle of a half caffeine, half decaf coffee drink. Now he replaces part of the original drink with 25% decaf. If the resulting drink is 30% decaf, what percent of the original drink was replaced? Dun, dun, dun. Okay, it's actually not that hard, but what we have to do in this case is we actually have to go backwards. What we're going to build is we're going to build the target amount after the substitution. We're going to build how much was substituted, and then we're going to figure out how much decaf we have in here after the substitution. So the first thing that I want you guys to pull out of this is, are we talking about caffeine or non-caffeine, decaffeinated? This whole thing's about decaffeinated, right? That's what we're substituting out, decaf. Well, we're given the target, right? The resulting drink, by the way, is 1 bottle. We're not allowed to have a bottle and a half. We're not allowed to have 3/4 of a bottle. We started with 1 bottle. We have to end with 1 bottle. That's the whole trick to these. And we know the value. It's got to be a 30% decaf mix, right? 1 bottle. So here's the thing. For the decaf, how much are we replacing out of the bottle? We don't know that, right? That's what we're being asked. How much are we replacing? We don't know. But we do know the percent decaf, right, that we're replacing. It's a 25% solution. So we got this full bottle. We're pouring out some, right? And we're filling up whatever we poured out with this 25% decaf solution. So let's talk about the original amount that we had. Well, the original amount that we had in the bottle was a 50-50 solution, right? Well, how much do we have left in that bottle of that 50-50 solution? We don't have a full bottle of it. We started with a full bottle, but we don't have a full bottle. We poured some out and we've substituted it with this 25% solution. So how much we must have must be a full bottle minus what else we substituted it with. That's the logic of that. Also, take a look at the consistency that we always can add thing 1, the amount of thing 1 plus the amount of thing 2 to get the total amount 1. So if we substituted X, the amount that must be of that original, or if I substituted X, the amount of that original solution must be a full bottle minus X. 1 minus X plus X will give us back to 1. And then all you do You just solve it. Let's try another one of these. These are tricky. Let's try another one, and we're going to add another layer of complexity because I know what you guys are thinking. Suppose this is easy. Can we please make this harder? Yes, yes, we can. So what we're going to do is we're going to do the same kind of thing, but we're going to add in kind of a ratio thing here. But it's going to work the very same way. We're going to work backwards. So a construction supply company delivered 100 pounds of a gravel cement mixture to a client that was 2/5 gravel. Unfortunately, the client required a mix that was 80% cement. How much mixture must the company remove and replace with cement to meet the client's requirements for the 100-pound delivery? Oh my gosh. We got all sorts of things going on in here. But you know what we know for sure? We know that our framework will always be correct. So the first thing we always pull out, look, this thing is either about gravel or it's about cement, right? That's what we got going on here. What are we substituting? Cement. This thing is all about cement, right? Let's talk about our target here. Well, we need 80% cement, and we're delivering 100 pounds of it. And that 100 pounds, it doesn't change. We're not allowed to deliver 110 pounds. We're not allowed to deliver 90 pounds. Got to be 100 pounds. Right. So we always work backwards in these. So substituted cement, well, we don't know. That's what we're being asked. How much cement do we need to substitute? Now, when we substitute this cement, are we putting in like some sort of diluted solution of cement? Or are we just like pouring in like full-on bags of cement? We're pouring in full-on bags of cement. We are replacing, not with like, a 25% cement solution, like we're doing in the decaf one. This is 100% cement. So that's one. So let's talk about the original kind of value that we had, right? Well, we're told that the original was gravel was 2/5 gravel. So gravel was 2/5. Gravel over total was 2/5. Well, that's great. Do we need gravel over total? We do not. This thing's about cement. We need cement over total. So we need to turn that into 3/5. So the value is 3/5 or 0.6. It doesn't matter. And how much of it will we have left after the substitution, right? We're doing this after the substitution. Well, we don't have 100 pounds of it anymore. Started with 100 pounds of it. That's not how much we have anymore. We have 100 pounds, but we've replaced X amount of it. 100 minus X. And notice the number of cement after substitution plus the substitution will get you back to 100. The amount 1 plus amount 2 has to equal 100. So if you go and do that, you're going to find that X equals 50. And that's about as deep into the mixtures and solution woods as they can take you. The framework will absolutely break down these questions. And look, they're going to use their whole thing is to try and give you information in the most confusing ways possible, right? That's literally the test job. If you try and get this stuff into, a weighted average framework, some of you might be really clever getting this stuff into weighted averages and doing it that way. Fine, but you still are going to have to do the same things here. Generally speaking, if you use this framework, it's going to be a more effective analytical tool to get all of their confusing language into a framework that you can actually solve. Because you know what? After you get it into the framework, how many people are going to take more than about, 30 seconds to solve the algebra? None of the algebra is hard, right? It's getting it out of the question and into the framework. This framework tends to be a better, more efficient, and more effective analytical tool for doing that than trying to put it in a big weighted average kind of, that kind of framework. All right. Guys, that is what I have. Oh, no, it's not true. I lied there just a little bit too. The other thing that they can ask is they can ask you back for a ratio. We love it when they do this. These are super simple. So a scientist needs to create solutions that is 40% of component A. Unfortunately, the lab only has a bottle of 20% component A solution and a bottle of 50% component A solution. In order to create a 40% solution, what percent of the total solution would need to be the 20% solution. Okay, so this is what we're going to do. First of all, we're just going to label some stuff here, and we're going to say, well, there's the framework. That's always the first thing we do, but we'll create some labels. X is the 20% solution. Y is the 50% solution. Now, what are we being asked back here? And this is very important. They don't need like the number of, the amount. They need a ratio. They need X over total, right? Amount of X over total. Because of that, because we're being asked back for a ratio, guess what? We get to use two variables. Whenever you're being asked back for a ratio, chances are you can use two variables. That is going to make this, we can make very short work of this. So we have X is a 20% solution, and we're going to add X amount of this 20% solution. And to that, we are going to combine a 50% solution. How much of that? Add Y amount of this 50% solution. And that's going to give us a target amount. Well, we know we need a 40% solution. How much are we going to have? We always add, the thing 1 plus thing 2. So that's 40% X plus Y. And you're thinking to yourself, Bruce, we can't solve this. We got two variables and one equation, but we don't need to get a particular value. We just need a ratio. So that becomes 2x plus 0.5y equals 0.4x plus 0.4y. That means 0.1y equals 0.2x, or 1y equals 2x. That means we got a ratio. X over y is 1 over 2. Remember, you need to be able to cross multiply that back out to get 1y equals 2x. Hey, guess what? Is one ratio 3 ratios? Yes. Yes, it is. If we get X over Y, what have we been asked for? X over total? Can we get there? Yeah. X over total has got to be 1 over 3. Boom. Just like that, 33%. When they ask you back for ratios, don't be afraid of two variables. Okay. And that's, by the way, true for the GMAT and the GRE generally. When you're being asked back for ratios, generally you don't have to be quite so, oh my gosh, I have to express everything in one variable. Usually you can get away with two variables, because if you get one thing equaling another thing, you can usually return whatever ratio they want. All right. So that is what I've got for you, plus one other thing. So because it is GMAT GRE week, I am running a special deal on a 10-hour package. So my 10-hour package is normally a $22.50, but I'm running a 10-hour package deal for $19.99. It's going to get through May, so you don't have to decide today, but you'll decide relatively soon. If you're interested, please reach out. My profile, by the way, you can get through that QR code, and I have lots of different packages available as well. This 10-hour package, by the way, is really good. If you're like just kind of trying to study for one part of the test, one side of the test, 10 hours often can either get you all the way there. You're very, very close to getting you to where you need to go. So if you're looking at just kind of studying for one part of the test, this is a great way to go. If you're looking to study for the entire test, I've got packages that can help you do that as well. All right, guys. Great job today. I know this stuff can be, a little challenging, a little tough, but you guys did great. Just keep practicing. And here's the other thing that I want to leave you with to kind of cap off GMAT GRE week here, and it's this. I know the GMAT and the GRE can seem intimidating. They work just like everything else in life. The more you practice, the better you get. So just keep going. All right, guys, that's what I have for you. Thanks so much. Bye-bye.